Good afternoon, everybody. Just let me know if you all can hear me, please. All right, cool. All right. All right, so this is my my fourth free session, right? As I've indicated in the previous sessions, I do give online maths, chemistry, and physics classes, right? All right, so what I'm going to be starting with today, I'm going to be looking at functions, right? Functions is a relatively long topic on the syllabus and it usually carries a lot of marks, right? So let's start by looking at a few questions first of all, right? So let's look at this here. This is an examination question. They are telling us, they give us two functions, f and g, and they've defined two functions for us, right? So one function, they're saying f is such that x maps onto 7x plus 4, right? When you see a function that is written like, one second, yeah, when you see a function that is written where you have f, two dots, and we have x and 7x plus 4, right? What this statement is saying is that f, right, is mapped onto, so these two dots here, these two dots mean is mapped onto x such that x is mapped onto 7x plus 4, right? Now let's work on how we answer questions like this. So they've given us f and g, and in part 1 they want us to work out g of 3, right? Now this here is my function g. So if you want to work out g of 3, all we need to do is to substitute 3 into that function. So it's going to be 1 over 2 multiplied by 3, and that's going to give us 1 over 6, right? So easy question. All you're doing is substituting the value of 3 into that equation, right? The second one, you want to find f of minus 2, right? This is f of minus 2. All we're going to do is to substitute into this function here. So therefore, anywhere we see x, we're going to put minus 2. So it's going to be 7 multiplied by minus 2 plus 4, right? So that is 7 multiplied by minus 2 is going to give me minus 14 plus 4, right? So minus 14 plus 4 is going to give me minus 10, right? So that's my answer for part 2. Now the third part now is a little longer, right? Whenever you see a function that looks like this, f to the power minus 1, right? That's what we call the inverse of a function. Now you guys need to be able to know how to find the inverse of a function, right? Now there's a procedure that we have to use in order to find the inverse of a function. So I'm going to go through the procedure here. So the function we are treating with is f of x, right? So the first thing I'm going to write down what the function is. So this is 7x plus 4, right? My first step is to let y equal to f of x, right? So therefore, y is equal to 7x plus 4, right? The next step in finding the inverse of a function is to interchange x and y, right? Now what that means is that anywhere we see x, we're going to put y, and anywhere we see y, we're going to put x. So therefore what we're going to say is x is equal to 7y plus 4, right? Now my next step is to make y the subject of the formula. So what I'm going to do, I'm going to say 7y plus 4 is equal to x. So therefore 7y is equal to x minus 4, and therefore y is equal to x minus 4 divided by 7. So therefore my inverse function, that's f inverse of x, sorry, is equal to x minus 4 divided by 7, right? So this is what my inverse function is. Now let's go back and see what the question was asking. The question is telling me here what? Find the inverse and plug 11 into that equation, right? So I found the inverse. So what I'm going to do, I'm going to substitute 11 into that expression. So it's going to be 11 minus 4 divided by 7, right? And 11 minus 4 is going to give me 7. So 7 divided by 7 is going to give me 1, right? So that's how we treat with a question like this, right? So be aware you could get a question like this in your exam next week, right? It's pretty straightforward. Once you know how to substitute, you're going to be okay. Now let's look at a slightly more difficult one, right? And this has to do with when they give us a function that looks like this. You need to be careful with these functions, right? Now, for part 1, we have a function here that is given by 2x plus 7 over x plus 1, right? And they want you to state the value of x for which the function is undefined. Now, I just want to tell you something about 0, right? 0 divided by any number is going to give me 0. But if we have a number divided by 0 that is undefined, right? If you try to work out that in your calculator, you're going to get an error, right? So any number, any variable divided by 0 that is undefined. So the question is asking me what value of x makes the function undefined. So what I need to do, I need to look at this value on top here. So the value to make the function undefined, the bottom part has to be equal to 0. So all we need to do here in part 1 is to say x plus 1 is equal to 0, and therefore x is equal to minus 1. And that's my answer there. So the value of x for which the function is undefined is when x is equal to minus 1, right? So keep that in mind. When you have a function that looks like this, and they want you to find the value for which the function is undefined, just put the bottom part of the expression, put it equal to 0, and solve for x. That's it. Now, part 2, right? You want to find gf of 5. Now, this is what we call a composite function. Now, there are two ways we can work this. What some students may want to do is to find the composite function g f of x first, and then substitute 5 into that function, right? That's one way, but that's a longer way. Unless the question asks you to work it out, don't worry too much about that. So what I would do, if I were you, I would do this. So gf of 5, what I would do first of all is to use a different color ink here. I would find f of 5, right? And when I get f of 5, I'm going to take that answer and I'm going to plug it into g, right? Now let me show you what I mean by that. So first things first, let's find f of 5. So f of 5, what that means is that I'm going to plug it into this function here, right? So that is 2 multiplied by 5 plus 7 divided by 5 plus 1, right? So we're just going to simplify this. So that's 5 2s are 10 plus 7 over 6. That's going to give me 17 over 6, right? So that's my value for f of 5. Now what I'm going to do now, I'm going to take that answer and I'm going to plug it into g. So I'm going to find g of 17 over 6. That's what I'm doing, right? So the answer that I just got for f of 5, I'm going to plug it into the function g. So this is going to be 4 multiplied by 17 over 6 plus 3, right? So you can use your calculator for this here. So that's 4 multiplied by 17 over 6. plus 3. And what that is going to give me is 43 over 3. Right? Let's make sure I didn't make a mistake here. It's 2x plus 7, so it's 2 5s are 10 plus 7, that's 17, and 5 more 1 6. Okay, so that seems okay there. I just found the answer look a little strange, right? So you worked out g of 17 over 16, and what that means is that my answer, which is g f of 5, right, is equal to 43 over 3, right? And that's my answer there. Now, the next part here, this one you need to be careful with, right? You're finding the inverse of this function here. So let's do this on the next page. F of x is equal to 2x plus 7 over x plus 1. 2x plus 7 over x plus 1, right? Now pay attention to this. If you do get a question like this in the exam, you are going to have to do some factorizing while you're finding the inverse. So we follow the same steps like we did before. So we let y equal to 2x plus 7 over x plus 1, right? Next thing we're going to do, we're going to interchange x and y, right? So if you've never seen these steps before, this is how we find the inverse. So we're going to interchange x and y. Right? What that means is that anywhere we see x, we're going to put y. Anywhere we see y, we're going to put x. So therefore, we're going to put x is equal to 2y plus 7 over y plus 1, right? So the next thing I'm going to do now, I'm going to cross multiply and try to make y the subject of my formula, right? Now, in order to do that, what I'm going to do, I'm going to write this x here as x over 1, right? The purpose of doing that is to help me to simplify, right? So what I'm going to do, I'm going to cross multiply because I have a fraction equal to another fraction. So I'm going to say this multiplied by this is equal to this multiplied by this, right? So what I'm going to write now, I'm going to put 2y plus 7 is equal to x, open brackets, y plus 1, all right? So this is 2y plus 7 is equal to, in order to remove these brackets here, we must use the distributive law, right? So that is going to give me xy plus x, right? Next thing we're going to do, remember the objective here, we're trying to make y the subject of the formula. So this is going to be 2y minus xy is equal to x minus 7, right? Next thing we're going to do, we're going to factorize because you have two terms in y. So this is going to be 2 minus x is equal to x minus 7, and therefore y is equal to x minus 7 over 2 minus x, right? X minus 7 over 2 minus x. Hopefully we okay there. Let me see. 2x minus xy, x minus 7. Right. So therefore, my inverse function, so this is how we write it at the end, is simply equal to x minus 7 divided by 2 minus x. Alright, so let's just look at this one here. I believe, just want to make sure. Okay, right, so let's do the next one here. Let's just to make sure we have things going here. We have two functions again, right? And they want us in part 1 to evaluate g3 plus g of minus 3. Now, we know what g is. G is this function here. So all we need to do in part 1, we need to find g of 3 first of all. So that is going to be 3 squared, and that's going to give me 9. Then we're going to find g of minus 3, which is going to be minus 3 squared, and that's going to give me 9, right? So therefore, if we want to work out g of 3 plus g of minus 3, right? All we're going to do here is to say 9 plus 9, and that's going to give me 18, right? So this is my answer for part 1, right? So you need to work out this first, then work this out, and just add the answers, right? Now in part 2 now, you realize they're talking about inverse. They want to find f inverse of 6. So here's what we do. We need to find the inverse of that function, right? So first thing we're going to do is to let y equal a half x plus 5. Next step we're going to do, we're going to interchange x and y. Right, so therefore it's going to be x is equal to a half y plus 5. Now, I don't like to work in fractions, so what I'm going to do, I'm going to multiply throughout by 2 to get rid of that fraction. So this is going to be 2x is equal to y plus 5. So therefore, y plus 5 is equal to 2x, and therefore y is equal to 2x minus 5, right? So therefore, my inverse function, so my inverse function, f inverse of x, is simply equal to 2x minus 5, right? So that's the first thing we do. Next thing we need to do here now is to substitute 6 into that expression. So f inverse of 6 is going to give me 2 multiplied by 6 minus 5. So that is 6 to the 12 minus 5, which is going to give me 7. Right? So that's my answer for part 2. Now, the last part, which is the third part, this again is a composite function. So what you should do here is to find what is g of 2, first of all, and that answer, we can plug it into f. So g of 2, right, is equal to 2 squared, which is going to give me 4, right? Then I'm going to take that 4 now, and I'm going to substitute it into the function f, right? So you're going to find f of 4 is equal to a half multiplied by 4 plus 5, right? Which is equal to half of 4 is 2 plus 5, and I'm going to get 7, right? So that's my answer there. So that's how we treat with composite functions, guys, right? Now, let me just give you an example of something here, right? Let's say I have f of x is equal to 2x plus 1, and let's say g of x is equal to, let's say, 2x plus 4 over x minus 1. And I were to ask you to find, let's say, f g of x. Right? They can ask you that, something like that in the exam. You want to find fg of x. Now this is a composite function here. What I need to do, I need to take the value of this, that is g of x, and I'm going to plug it into f, right? So this whole thing here, right, I'm going to take that and I'm going to plug that into this equation, but I'm plugging that in as x, right? I hope that kind of making sense there, guys. So fg of x is simply equal to 2 multiplied by 2x plus 4 over x minus 1, right, plus 1. So that is fg of x. You can go ahead and you can simplify that if you want, right? I'm just trying to make sure you kind of understand the concept. They could also ask you to find g f of x, right? What that means is I'm going to take f of x and I'm going to plug it into g. So what I'm going to do here, I'm going to take whatever the value of f of x is, which is 2x plus 1, and I'm going to plug it into this expression here. So that is going to be 2 multiplied by 2x plus 1 plus 4 over 2x plus 1 minus 1, right? I can simplify this one here. This is going to give me 4x plus 2 plus 4 all over 2x plus 1 minus 1. And if I simplify this, I'm going to get 4x plus 6 on top over 2x at the bottom, right? So this is how we find the composite function, right? So we have another question here. This question came in January 2020. That's the last written paper that they had, that CSEC had, right? So this first part here, they gave us one function, that's f of x, and they said find f of 4 plus f of minus 4. So all we need to do here is to find f of 4, right? And that's going to be 2 multiplied by 4 plus 7 over 5. And that's going to give me 8 plus 7 over 5. And that is 15 over 5, which gives me 3. Next thing we need to do is to find f of minus 4. And that's going to be 2 by minus 4 plus 7 over 5. And that is minus 8 plus 7 over 5. Minus 8 plus 7 is minus 1. So this is minus 1 over 5. So to get f of 4 plus f of minus 4, all we're doing, we're adding those two answers that we got there. So this is 3 plus minus 1/5, right? Which is going to give me 2 2/5, right? But let me give you so you can leave your answer as 14 over 5 if you want, right? So this is my answer for part 1. In part 2 now, part A, calculate the value of x for which f of x is equal to 9. Now, when you get a question like this where they say f of x is equal to 9, right? This is my function here. So if f of x is equal to 9, all I'm going to do is to put the function equal to 9, right? So I'm going to put 2x plus 7 over 5 is equal to 9, right? So therefore, 2x plus 7 is equal to 9 multiplied by 5. So 2x plus 7 is equal to 45. 2x is equal to 45 minus 7. All right, let's go across here. So 2x is equal to 45 minus 7 is 38. So therefore x is equal to 38 over 2. So therefore x should be equal to what? 19? Yeah, so x is equal to 19. Right? So my answer for this one here is 19. Right? And then this part B here now, hence or otherwise determine the value of f inverse of 9. Right? That's what I want. What is f inverse of 9? Now, let me just get a blank sheet here. So we just worked out f of x, right? When f of x is equal to 9, right? Yeah, f of x was equal to 9, and the value of x that we worked out, we got x is equal to 19, right? So what that means is that if I have a function here, right, and I plug into this function, I plug 9 into this function, I am going to get 19 as my output, right? So when we move in that direction, we are using f of x. But if I want to go from here back to this, right, what I'm going to use my inverse function. So what that means is that when I plug 19 into the inverse function, I'm going to get 9. So let's see what the question is asking. The question wants f inverse of 9, right? So the question wants f inverse of 9. So what they're saying here is this. F inverse of 9 is equal to what, right? Oh wait, sorry, I just realized something. Hold on. I wrote this wrong here. Sorry about that. This is, we're plugging 19 into the function and we get to 9, right? So when we plug 9 into the inverse function, obviously we should get back 19. So this is what the question, this is the answer for the question, right? But you didn't have to work out anything. The fact that you solved for x just now and you got 19, it means when you plug 19 into the function, you would have got 9. So if you take 9, right, that's this, and plug it into this function here, which is the inverse, I'm going to get 19, right? So my answer is 19. There's no calculation for that part of the question, right? CSEC just wants to see that you understand what you're doing there, right? What inverse actually means. All right, so let's move on now. So that's basically what you need to be able to do with functions, right? The next thing we need to be able to do, we need to be able to plot points on a graph, right? So if I were to tell you to plot the point, let's say 2, -1, right? What that means, this value here is my x coordinate and this value here is my y coordinate, right? So therefore x is 2 and y is -1. So what you're going to do, this is -1 here and this is 2. So this is my point E, right? Make sure you understand on a graph, you have two axes. You have your x-axis, which is your horizontal axis, and your y-axis, which is your vertical axis. So if I were to tell you to plot the point B, which is, let's say, 4, 5, right? It means my x coordinate is 4, so you're going to go up here. And my y coordinate is 5, so you're going to go. So this point here is 4, 5, right? Similarly, if I had something like C being, let's say, -5, -2, right? If you had to plot that coordinate, you go down to -5 and you're going down to -2. So this point here is my C, right? So guys, you need to be able to plot points in a graph. The next thing you need to be able to do, you need to be able to draw a straight line. If they gave us a function in the exam like this and they told us we need to draw a straight line, all we need to do, we need to substitute some values of x into that formula and then we can plot the graph. So this is our function, f of x is equal to 2x plus 5. So we're going to choose some values. So I'm going to choose, let's say, f of 4. I'm going to choose 4. So that'll be 2 by 4 plus 5, which is giving me 4 2s are 8 and 5 is 13. Actually, I may have to choose something smaller than that because I won't be able to draw it on this graph here, right? Just now, I feel I copied the wrong. Alright, just now. Let's plug f of 0 into it, right? So f of 0 is going to be 2 by 0 plus 5, and that's going to give me 5, right? So what that does, that gives me a coordinate of 0 and 5, right? That's what that does. So 0, 5 is actually this point here, right? Let's find f of -1, right? And that's going to be 2 by -1 plus 5. So -2 plus 5 is going to give me 3. So that coordinate is going to be -1, 3. So I'm going to plot that, -1, 3. Now, if you have to plot a straight line, all you need you just need 2 coordinates, right? But what I tell my students to do is use 3 coordinates just in case you made a mistake with your working, right? So let's say I plug in -3 into this, and I get 2 by -3 plus 5, and that's -6 plus 5. That's going to give me -1. Is that correct? Yeah, -1. So therefore, that coordinate will be -3, -1. So that is here, right? So all you do now, you draw a straight line that passes through these points here, right? So you use a long ruler in the exam and you draw a straight line. So this function that we've drawn here is actually 2x plus 5, right? So you have to be able to plot a straight line graph in the exam, right? The next thing you need to be able to understand, you need to know what are x and y intercepts. Now, intercepts are simply where am I cutting my axes. So my x intercept, right, is actually where am I cutting my x-axis. I am cutting, remember, this is my x-axis here. So I'm cutting my x-axis at this point here. The coordinate of that point is -2, 0. A common mistake for students will be to give your x-intercept as 0, -2. That's incorrect. We always state whatever the x value is first, right? My y-intercept is where am I cutting my y-axis. That's that point here, right? So the y-intercept will be 0, 4, right? Be careful of how you are stating coordinates. That's a mistake that students make. Huh? Now, the next thing you guys need to be able to know, you need to be able to know how to find the equation of a straight line, or you need to know the general form of the equation of a straight line. So all straight lines follow this here. It looks like y is equal to mx plus c, where m is a constant, right? That m is what we call the gradient of the line. I'm going to talk more about this just now. And this c is my y-intercept. Right? Now, if we look at this equation here, that equation is y is equal to 2x plus 3. So what that tells me is that my gradient is equal to 2. So my gradient of this line is 2. Right? My y-intercept is this point here, is actually at 3. But how we write the y-intercept, we write it as a coordinate. And that coordinate is written as 0, 3. So that's my y-intercept. Now if you had the graph, you can just read it off here. You know? This is my y-intercept. And the coordinates of that point is actually 0, 3. So on the graph, I can figure out my y-intercept, or I can get it if I know the equation of the straight line. Right? Now, one of the biggest challenge that students have, and I noticed that CSEC would have given some questions recently where students had trouble identifying what the gradient was. So if you have an equation that looks like this, right? Let's say 2y is equal to 4x plus, let's say minus 5, right? And I would ask you, what is the gradient of this line? You know what's the first thing some students are going to tell me? They're going to say it is 4. And that is incorrect. It's not 4. Because this equation must first be written in the form y equal to mx plus c. It has to be written in this form first. So in order to do that, we can say that y is equal to, just divide every single thing by 2. And this will give me y is equal to 2x minus 5 over 2. So my gradient, or my m, is equal to 2, and my y-intercept is equal to 0 minus 5 over 2, right? So you have to be careful with questions like these. Huh? If you had something like, let's say, x over 2 plus y over 3 is equal to 1, right? So some students might watch that and be like, wow, how are we going to find the gradient and the y-intercept? Well, all you need to do in this case here is, because you have x over 2 is a fraction, y over 3 is a fraction, and 1 could be written as 1 over 1, we simply multiply by our LCM, the LCM of 2 and 3, which is 6, right? So therefore, this is going to become 3x plus 2y is equal to 1. So therefore, 2y is equal to minus 3x plus 1. So therefore, y is equal to minus 3 over 2x plus a half, right? So therefore, my gradient m is given by minus 3 over 2, and my y-intercept, right, is actually 0, a half, right? So your y-intercept is really a coordinator. So pay attention to this, right? I've seen, I think it's in the June, maybe 2019, 2018, they brought a question like this, and students had trouble with it. Next thing we need to be able to do, we need to actually figure out the gradient if I know 2 coordinates on the line, right? And this is our formula for gradient. It's always my difference in y divided by my difference in x. So first things first, let's figure out the coordinates of these 2 points A and B. So A is actually 2, 4, and B in this case here is 6, 12, right? And I want to find the gradient. So whenever you get a question like this in the exam, you always write down what the formula is first. It's y2 minus y1 divided by x2 minus x1. Don't mix up, don't put x on top and y below, because you're going to get it wrong. So this is what I usually teach my students to do. Once you know the 2 coordinates, please label them. So what I'm going to do, I'm going to label this as my x1. This is going to be my y1. This here is x2, and this here is going to be y2. right? So I've labeled them. So all I need to do now is to plug those numbers into my formula. So y2 is actually equal to 12 minus my y1, which is equal to 4, divided by x2 minus x1, which is 6 minus 2. So therefore 12 minus 4 is 8 and 6 minus 2 is 4. So therefore my gradient of that line segment AB is actually equal to 2, right? That's what my gradient is. So you have to be able to find the gradient when you are given 2 points. Next thing. The next thing they can ask us to do is to find the equation of a straight line, right? And they can give us information or they can draw a graph for you. So what I'm going to do here, the first thing you need to remember that the equation of any straight line is of the form y equal mx plus c, where m is my gradient and c is my y-intercept. So I just showed you how to find gradient. So we should do that. We should find the gradient of that line segment first. So y2 minus y1 divided by x2 minus x1, right? So let's write down the coordinates of a here. So a in this case is 1 minus 1, and b in this case here is 3, 5, right? So first thing we need to do, label your points so you will not make a mistake, right? So you're going to call this here x1, y1, and call this x2, y2, right? Once you do that, then it's just a matter of substituting. So y2 is actually equal to 5. So it's 5 minus y1, which is minus 1, divided by x2, which is 3, minus 1. So that is 5 minus minus 1 is going to give me 6, and then 3 minus 1 is going to give me 2. So my gradient of this line is actually equal to 3, right? So you figured out what m is, you know. So you can say that the equation of the line looks like this. Y is equal to 3x plus c, right? So the only thing you really need to figure out now, you need to figure out what c is. So here's what you're going to do to figure out c. You can either choose the point A or the point B or any point on that line as a matter of fact, and substitute it into this equation so that we can figure out what c is. So I'm going to use the 0.35. So you're going to say using 35, right? That means that when x is equal to 3, y is equal to 5. That's what that means. So I'm going to substitute that into my equation. So 5 is equal to 3 multiplied by an x3 plus c. So this is 5 is equal to 3 3s are 9 plus c. Right? So 9 plus c is equal to 5. So therefore c is equal to 5 minus 9. Therefore c is equal to minus 4. So therefore my equation of my line is equal to y is equal to 3x minus 4. Right? That's my answer. Now this is a typical examination question, guys. So make sure you understand how to do this. So Joshua asking if it's okay if we put it the opposite way. But that's fine. That's fine. Now, the next thing you need to know about straight lines, you need to be able to know something about parallel lines. So in maths, we have something called parallel lines, right? So I've drawn 3 lines for you guys here. So I have P, line Q, and line R. Those lines are parallel. Now, how do we know they're parallel? If you extend those lines until infinity, they will never meet. So parallel lines never meet, right? Now, there's something that you need to know when it comes to parallel lines. They all have the same gradient, right? So look at this. So line P, that's this one here, has an equation of y equal 2x plus 4. Line Q has an equation y is equal to 2x. And line R has an equation y is equal to 2x minus 4. So if you look carefully, you realize, wait a minute, look, the gradient of this first line is P and it's 2. The gradient of the second line is also 2. And the gradient of the third line is also 2. So parallel lines have the same gradient. You guys need to know that. Anytime you see a question where they're talking about parallel lines, we are talking about the same gradient, right? You also need to know something about perpendicular lines as well, right? So I have two lines here that I've drawn. I have the first one, which is line P, and then I have the second one, which is line Q. Those two lines are perpendicular. They meet at some point, right? But the angle between those two lines here are 90 degrees. Like where they intersect, right? They intersect and the angle they make with each other is 90 degrees. So that's what we mean by perpendicular lines, right? So, but here's the thing. There is a rule when it comes to perpendicular lines. The gradient, all right, if you take the gradient of each of the two lines and you multiply them, you are going to get -1. You're going to get -1. That's an important concept you need to remember. So in the case of line P, right, that's this one here, the gradient is equal to 2. And for line Q, the gradient is equal to -1/2. So look at this. So if I multiply those two gradients, right, if I take 2 and I multiply by -1/2, I'm going to get -1. The fact that I'm getting -1 tells me that those two lines are perpendicular, right? Now let me show you how we're going to use that now to answer certain questions. So look at this question here. We have a line L, right? That's the red line you see in there. And we know the equation of that red line. It is y equal to x minus 5. Determine the equation of the line which is parallel to L, right, and passes through the point P. So when you get a question like this, try not to get confused. You have a line L, which you know the equation of, but the question is asking me, find the equation of the line which is parallel to L, but it passes through the point P. So they're talking about a line, visually this is what's happening. You're talking about a line that does this, right? I know mine are looking too parallel here, but this is the line that they want us to find. They want us to find the equation of that line. So first things first, you need to figure out the line L. This is the equation of line L, right? So therefore, the gradient of line L has to be 2. But because the line that we want to find is parallel to that, we know the gradient of that line, right? It has to be 2 as well if it's parallel. So the gradient of L is equal to 2. Therefore, gradient of line that passes through P, right, is also equal to 2. And that's because it's parallel, right? So what we do know is that equation that we want to find looks like this. Y is equal to 2x plus c, right? But we don't know what c is. So here's what we're going to do. We're going to look and see what the coordinates of P is. So the coordinate of P is actually 1, 2, right? That's the coordinate P. So what that tells me is that when x is equal to 1, y is equal to 2. So what I'm going to do now, I'm going to take those two numbers, the x equal 1 and y equal to 2, and I'm going to substitute it into this equation here and solve for c. Because if I find c, then I already figured out the equation already. So let's do that. So 2 is equal to 2 multiplied by 1 plus c. So therefore 2 is equal to 2 plus c, right? So therefore c is equal to 2 minus 2. So therefore c is equal to 0. So the answer, right? So my answer, right, for the equation that they want is y is equal to simply 2x, right? It just so happened that c worked out to be 0 in this case. All right. So this is a typical exam question. Huh? Let's see if we have one. All right. So this one here now, we have a line L, right? That's this line here, the red line. We know what the formula is. Y is equal to half x minus 1. Determine the equation of the line which is perpendicular to L but passes through P. So this is what they're asking us for. They want to know what is this line because we want a perpendicular line, right? That line has to meet at 90 degrees. So first things first, we need to look at the equation of the line L, right? As this equation here. From this equation, we see that my gradient is equal to a half. Therefore, if we know that gradient, we know the gradient of this line here, right? So you have to think about it. What number, when I multiply by a half, am I going to get minus 1, right? So what I usually tell my students to do, you just invert it. So it's a half, so we're going to invert it. So it'll be 2 over 1, and we put a minus sign there. So the gradient has to be minus 2. So this is what we're going to write. So gradient of L is equal to a half according to the equation. So the gradient of perpendicular line has to be equal to minus 2. So let's write the equation of that line we're trying to find out. So it should be y equal to minus 2x plus c. We don't know what c is, right? So what we're going to do, we're going to have to use the point P in order to figure out what c is. So P is equal to minus 3, 2, right? So what that means is that when x is equal to minus 3, y is equal to 2, right? So we're going to substitute. So we're going to say 2 is equal to minus 2 multiplied by minus 3 plus c, right? So 2 is equal to minus 2 multiplied by minus 3 is going to give me 6 plus c, right? And therefore c is simply equal to 2 minus 6. So c is equal to minus 4. So my answer, right, for my equation that they want us to find is going to be y equal to, what's my gradient? Right, so minus 2x minus 4, right? All right, somebody asked me if they can use the formula. Yes, right? So those of you doing add maths might be familiar with that formula. There is another formula we can use to find the equation of a line, and you can use it if you want, right? And that formula looks like this, right? CXC is not specific as to which one to use, so let me show you what I mean. So there is another formula that we could use to find the equation of a line, and that formula looks like this. Y is equal to y1, which is equal to m, open brackets, x minus x1, right? This is another method that you guys can use. It is up to you. I don't usually teach this unless it's add maths, right? I prefer students understand the y equal mx plus c, right? But this is an easy method to use as well. Now, the next formula that you guys need to be familiar with is finding the midpoint of a line segment, right? And this is my formula here for midpoint. All you need to do, once you know the two coordinates, right? Now, I want you to remember that midpoint is a coordinate. So look at it there. It's not a formula here. It's a coordinate. Notice it's a comma separating the two values. So all you're doing is taking the two x values and divide by 2. It's midpoint. Add the two y values and divide by 2. That's it. Nothing complicated with midpoint, right? If you get something like that in the exam, that's easy stuff. So look at this here. Determine the midpoint of the line joining these 2 points, P and Q. So just write down what P is. So P is minus 4 and 7. Q is 6 and 1. Again, just like when we were labeling to find gradient, do the same thing here. Call this x1, call this y1, call this x2, call this y2. Once you label this, guys, there's no way for you to make a mistake. You wouldn't believe how many students, they confuse the x1s and the y1s and the y1s and the y2s, right? So my midpoint is a coordinate, right? So let us call the coordinate m. Write down the formula first. It's x1, we add any two x values and divide by 2, comma, y1 plus y2, and we divide by 2, comma, close bracket, sorry. And this is what we're going to do. So we're going to say minus 4 plus 6 divided by 2, comma, and then 7 plus 1 divided by 2. And what I'm going to get here, minus 4 plus 6 is going to give me 2. So this is 2 over 2. 7 and 1 is 8, 8 over 2. And therefore, this is going to give me 1, 4 as my midpoint, right? Right, So next thing, a next formula that you guys need to know, you need to know how to find my length of a line segment, right? Now this formula is essentially Pythagoras Theorem. It looks confusing, but it's not really confusing, right? This triangle here is a right angle triangle. And if I want to find the length of AB, all I need to do is I need to know what is this distance here. That distance is actually x2 minus x1, right? That's what that distance is. You need to know this distance here, which is y2 minus y1. That's this. So therefore, if I want to find this using Pythagoras' theorem, right? The length AB squared, Pythagoras' theorem says that the hypotenuse squared is equal to the sum of the squares of the other two sides. So it's going to be x2 minus x1 squared plus y2 minus y1 squared. All right. So therefore, AB, the length AB is simply equal to the square root of all of this, right? Which is x2 minus x1 squared plus y2 minus y1 squared. Now this formula is not given to you in the exam. None of these formulas here, all right? Except maybe y equal mx plus c, which you should know that. But this is what you need to remember. This is how we find the length of a line segment. So let's look at something here. Let's say we want to find the length of this line segment here. The coordinates of the point A, right? We need to know what those things are. So this is 1, 2. This one up here is 7, 10. Again, what I advise people to do is to label them. So this is x1, this is y1. This is x2, this is y2, right? This helps and prevents confusion when you're trying to use a formula, right? So we're going to use a formula here. So my length is x2 minus x1. So that'll be 7 minus 1 squared plus 10 minus 2 squared, and you're going to find the square root. So 7 minus 1 is 8, right? So that's 8 squared plus 10 minus 2, I'm sorry, not 8, 6. Crazy maths are doing here. All right, 7 minus 1 is 6, and 10 minus 2 is 8 squared square root. So this is going to give me 6 6s are 36 plus 64, and you're finding the square root. 36 plus 64 is 100. You find square root, and that'll be 10. And please just write units as your answer. Don't just put 10. You're finding length, so you're going to put 10 units, right? Right, so look at this question here. This question actually came in January 2020, right? So that was the last written paper by CSEC. So they gave them two lines, L1 and L2, right? And just by looking at the two lines, you can tell that the two lines are perpendicular, right? We can tell that. But let's see what they want us to do. Let's see, I think I need a blank sheet. Do I? Yeah, I do. One sec, I just need to get a blank sheet so we can work the problem, right? So let's look at the question. So they give us some information here. They said L1 intercepts the x and y axes. So they've given us the coordinates where these lines cut the x and y axes. So L1 cuts here, and it also cuts here. In the case of L2, L2 cuts at this point here, as here, and it also cuts here. Right? So that's all they're telling us here, right? So they're not giving us any new information that we can see from the diagram either way. So in part 1, they want us to determine the equation of the line L1, right? So in order to find the equation of the line, you must know what your gradient is, and you must know what your y-intercept is. Now, I'm going to show you something here. You don't need to calculate the y-intercept because you can read it off from the graph. This is 0, 2. So I know what my C is for that equation already. So all I really need to do is to find the gradient of L1. This point here, this coordinate here is actually 4, 0, right? So what I'm going to do, I'm going to label my x1. So I'm going to label this as x1, y1. I'm going to label this as x2, y2, right? So let's work out the gradient of L1. So gradient of L1, right, is equal to y2 minus y1 over x2 minus x1, right? So what is my y1 and y2? So y2 is 0 and y1 is 2. So it's 0 minus 2. So it's 0 minus 2 divided by 4 minus 0. So that's going to give me minus 2 divided by 4, and that's going to give me minus a half, right? So that's the gradient of L1. But we already can tell from the graph that the y-intercept is 0, 2, right? So my y-intercept, right, is 0, 2. So equation of L1, right, there's nothing there to work out. We can say the equation is y equal to minus a half x plus 2. Because look, this is my y-intercept here, right? So that's my answer for the first part, the equation of L1, right? That's part 1 here. The next thing, what is the gradient of L2 given that L1 and L2 are perpendicular? So they want you to work out the gradient of this line, L2, right? Given that the two lines are perpendicular. Can you all tell me what the gradient of L2 is? L1 and L2, they are perpendicular. So what's the gradient of L2? Let's see if you're all paying attention. Alright, so I see Mikkel saying 2, and yes, that is correct, right? So yes, the gradient is 2. Because if the gradient of this line here is minus a half, right? That's minus a half. The gradient of this one has to be 2. Because when I multiply minus a half by 2, I'm going to get minus 1. Remember, perpendicular lines, when you multiply their gradients, you're going to get minus 1, right? So yes, the answer for this one here is 2. All right, let's talk a little bit about quadratic functions, right? So there's a special function that CXC loves, both for CSEC maths and for ad maths, right? They love to bring things about quadratic. So a quadratic function looks like this: ax squared plus bx plus c. Now what does that mean? If I have a function that looks like this, 2x squared plus 5x plus 1, that is a quadratic. Now, what makes something a quadratic is the fact that you have an x squared term, right? So if I had something like this, f of x is equal to 2x squared plus 4x, that is still a quadratic. If I have something like f of x is equal to just 2x squared, that is still a quadratic. If I give you something like this, f of x is equal to 4x plus 1, this is not a quadratic, right? Because there's no x squared term. So if you never heard that before, a quadratic must have an x squared term in it, right? So that's what a quadratic essentially looks like. In terms of a graph, a quadratic graph, right, looks like this, right? But the thing is, there are two kinds of graphs. The graph can either have a minimum point or a maximum point, right? Make sure you know the shape of this graph. It's called a parabola, right? They could ask you that in the multiple choice paper, right? So that is what we call a parabolic function, right? And it's a quadratic. Now, if we know the equation of a quadratic, we can tell if the graph is going to look like this or if the graph is going to look like this. What we need to do, we need to look at the coefficient of x squared, which means we're looking at the number that is in front of x squared. So look at this. So whenever a is positive, so if that number is positive, my graph is going to look like this. It's going to have a minimum value, right? It's going to have a minimum value. if A is negative, it's going to have a maximum value. So, for example, if I had an equation that looks like this, y is equal to x squared plus 3x plus 2, right? I know for sure that this graph is going to look like this, and it's going to have a minimum point, right? Because my coefficient here is positive. But if I had something like this, y is equal to minus 2x squared plus 5x plus 1, I know for sure that the graph is going to look like this. It's going to have a maximum point, right? Now, when it comes to a quadratic, there's certain things that you need to know. A quadratic actually has a mirror line, right? There's a line that I can draw through my maximum point or minimum point that if I fold the graph paper, right, the left and right side going to line up exactly. So this here is called my mirror line, right? That's called my mirror line, right? This here is called my minimum point. So this here is my minimum point, right? Again, if we look at the maximum graph, again, it's going to have a line of a mirror line, right? Now, the word that we use for just now, right? Let's use the proper word for it. Now, think of it as a mirror line, but the actual name for it is called my axis of symmetry, right? That's what we call it. So this here is my axis of symmetry, right? And this here is my maximum point. Right? Now, I want you to remember something as well. When they ask you for the maximum point, right, that's usually given as a coordinate, right? So it'll have an x value and a y value. And when they ask you for the axis of symmetry, it is given as an equation like this. X is equal to something. Now, there is a formula to find the axis of symmetry, you know. The formula is this, minus b over 2a. That's how we find the axis of symmetry. But then somebody might say, so where you get b and a from? The quadratic function is written like this, ax squared plus bx plus c. So if you had an equation that looked like this, y equal to 2x squared plus 3x plus 1, let's say I had an equation like this. What that means is that a is equal to 2, b is equal to 3, and c is equal to 1. I'm getting those numbers from here. This 2, this 3, and this 1, right? And these are the numbers here that I need to plug into this expression. I don't need the c, but if I have b and a, I can work out the axis of symmetry. Right? I know some of you all may never have seen this before. Right, now let's look at an exam question related to the quadratic function that CSEC likes to bring, right? Now there are different things. If they give you a graph, they can ask you certain things about the graph, right? Now let's see if we can answer this question here. So the first part, hopefully you all kind of seeing it there. Let me just make this a little bigger here so you could. So they give us a graph, right? They said the graph shows a function this, which is a quadratic. Now in part 1, they want to know the value of f of x when x is equal to 0. Can anybody say what that answer is? What is the value of f of x when x is equal to 0? 1 mark for that. Anybody know what the answer is? Joshua is saying -3, 0.5. Now, all they want you to do, they're asking you, what is the value? Remember this graph here that they've drawn is actually f of x, right? So what is the value of f of x when x equal to 0? All you need to do, remember your x-axis is here. So all I'm going to do, and this is where 0 is, x equal to 0, I'm just going to go up to the graph and see where that is. That's this point here. So the answer is simply f of x is equal to 3. That's the answer for 1 mark. That's all you write it, right? So I'm not sure how you all get in -3, right? But the answer is 3, right? All you're doing is plugging in 0 when x equals 0, and you're going up and see where that's this point here, right? So that's the answer for part 1. For part 2 now, they want to know the values of x when f of x is equal to 0, right? Now, the x-axis is also called my line y is equal to 0. That's the equation of my x-axis, right? Always remember that. Now, how I used to remember it in school is that the x-axis is the opposite. So therefore, the equation is going to be y equal to 0, right? Now, when they tell you f of x equal to 0, what that is asking you there is, where does my graph cut my x-axis? That's all it's doing. So my graph cuts my x-axis at this point here and at this point here. So the values of x, so this is what you're writing for your answer. You're going to say x is equal to -3, comma, x is equal to 1/2 or 0.5. That's my answer for part 2, right? So be careful. I saw some of you all said something different for part 1, right? So be careful, don't confuse the answers. So the answer for part 1 is f of x is equal to 3. For part 2, you have two answers, x equal -3 and 1/2, right? So 2 marks for that. The next part, they want to know the coordinates of the maximum point. Can you all tell me from the graph, I hope you all could kind of see it, what are the coordinates of the maximum point? So I don't know how good it's showing on your screen, right? To be able to see what the maximum point is. So what's he actually really trying to do? I notice it's 2 marks, right? So all you're doing, the maximum point is actually here, this point here. That's my maximum point. So if I look at this graph, that is -1 point. Now your value might be slightly different, right? So it's I'm getting -1 point, let's say 3, comma, and I'm going to get 6.1, right? So all you're doing, you're just reading off the coordinates of that point. That's all you're doing, right? Right? Sharice, remember we put in the x coordinate first, right? The next thing they want us to do, what is my equation for the axis of symmetry? Now, once you know what your maximum or your minimum point is, my axis of symmetry, that's this line they're talking about here. This line that if I do this, if I draw a line going on here, that's my axis of symmetry, right? And that line is simply going to be x is equal to -1.3. That's my answer there, right? Whatever you got as the x value in the previous part of the question, that is the equation of my axis of symmetry. Now CXC gave you 2 marks for this because no student's going to get that wrong, right? So my axis of symmetry, all I'm doing is reading off whatever the x value of that maximum point is, which is minus 1.3. Right? The next thing they want now in part 5, the values of x when f of x is equal to 5. Right? F of x is equal to 5. Again, you have to be careful with this one, right? And they're giving you 2 marks for this. The values of x when f of x is equal to 5. Now, you all need to understand what this means, right? When they say f of x is equal to 5, what that really means is that you want to know where does this graph, the quadratic, cut the line y equal to 5. That's what that question is telling you, right? So you see like how in this part here, we wanted to know where does the graph cut my x-axis, right? That equation of that line was y equal to 0. So when you have f of x is equal to 5, what you have to do is to come to the graph and you're drawing a horizontal line here. Right? It's going to intersect the graph at 2 points. So that line that I'm drawing here is y equal to 5. So that's what you're doing. You have to draw the line y is equal to 5. The points that they want, the values that they want will be this. This is one point of intersection. And this here is another point of intersection. So my answers will be x is equal to minus 2, comma, we have our next value here. That is actually minus, x is equal to minus 0.5. Right? I know some of you all may have not seen this before, right? But that is what we do. I chose this question because this had all different variations of the things that it can ask you, right? And the last part here, part 6, the interval within which x lies when f of x is greater than 5. F of x is greater than 5. All right. Now, this is the next part that confuses students. So we just drew the line y is equal to 5. Right? So if you look at this here, this equation and this is kind of similar. The only difference is we have a greater than sign here, right? So let me just draw a little sketch here to show you what's happening. So we have this here, right? That's our line y equal to 5. And we have our quadratic that looks like this. And we know this point and we know this point. We know that. But the question wants to know f of x greater than 5. What that is really asking me is that on my graph, where is my function greater than 5? So let me use a different color to show you exactly what I'm talking about. So this value here was minus 2 and this value here was minus 0.5. Right? Those are these points here. This point and this point here. Now, between minus 2 and minus 0.5, notice something. My graph is actually greater than the line y equal to 5. It is above the line, right? And anything that is, use a different color here again. This part here, this part of the curve is below the line y equal to 5, and this part of the curve is also below. So only the green part is telling me that my curve is above my line y is equal to 5. Now, this is how you're writing your answer for the last part. You're going to say x has to be greater than minus 2 and it has to be less than minus 0.5. That's how you're going to write your answer. Look, they told you that. They told you they want you to write the answer like this, right? Now, I hope this question kind of open up your eyes a little bit because these are things that could potentially ask you in the exam, right? Let's go through quickly if they were to ask us to draw a graph, right? A lot of the times in the exam, they're going to ask you to plot a graph. They can actually plot a straight line or a curve. In this one here, I've given you an equation here. And the domain has to do with the x values I'm going to plug into my equation, right? And they might give you a table to complete. But what they might do, they might actually give you some of the values in the table, and you might just have to work out one or two values. So look at something here. What you should do to complete this table, you're going to substitute each of these values here. You're going to take -1 and plug it into the function. So f of -1 is going to be equal to -1 squared minus 4 by -1 plus 3. So this is going to give me 1 minus 4 by -1 is going to give me plus 4 plus 3, and that's going to give me 8, right? Then you plug in, so this is 8 you're going to put here. Then you're going to plug in 0. So f of 0 is going to be 0 squared minus 4 by 0 plus 3. So this is going to be 0 minus 0 plus 3, and this is going to be 3, right? This is going to work out one more for you guys, right? So let's say we work out f of 1. That is going to be 1 squared minus 4 by 1 plus 3. So this is 1 minus 4 plus 3. And 1 minus 4 is minus 3 plus 3 is going to give me 0. So this is 0. So you do the same for all of these here, right? And then you go ahead and you plot the graph, right? So what I've done here, I've plotted the points for you guys, right? And this is what the graph is going to look like. So that could potentially be an exam question. They could probably give you maybe 5 or 6 marks to draw a graph like this, right? And then come and ask you things like these about your graph, right? So what's the time there? 3:16. Let's see. Let's see if I can get some more questions inside here. Right. Now this is the next question that CXC likes to bring, right? And this particular question has to do with completing the square, right? That's what this is about, right? So what they will do in the exam, so practically all the questions that come on completing the square, they will say write this quadratic in this format, right? Now what I typically do with this question here, so 3 marks for that, right? So let's write it down. F of x is equal to, so this is my equation. F of x is equal to 2x squared minus 4x minus 30 minus 4x minus 30, right? And they want us to write that in the form a open brackets x plus h squared plus k, right? Now there are different ways that you can work this question, right? Some students can look at this and they can write it in that form very easily. Let me show you one method that you can use as well. So you can use a method called expanding or equating coefficients, right? So we can do this. We can expand this expression here by doing this, right? X plus h squared is actually x squared plus 2hx plus h squared plus k. So this is ax squared plus 2a hx plus a h squared plus k, right? So this is just one method you could use, right? Some students might use a different method. So what we're going to do now, we're going to equate our coefficients. You're going to look at this expression here and look at this expression here, right? So if we equate coefficients, right, you can see we have an x, we have 2x squared here and we have ax squared here. So what that tells me is that a is equal to 2. So look, I figure out a already, right? Next thing, we have only one term in x, and that's this here, 2ahx. So we can say that 2ah is equal to minus 4, but the thing is you just worked out what 2 was, what a was, sorry. So a is 2, so this is minus 4. So therefore 4h is equal to minus 4, h is equal to minus 4 over 4, h is equal to minus 1, right? So I've gotten h. Next thing we need to do, we need to figure out k. The only thing left now is AH squared plus K, and you're going to put that equal to minus 13. So AH squared plus K is equal to minus 13. So we know what A is. A was 2 multiplied by H squared, which is minus 1, plus K is equal to minus 13. So minus 1 squared is 1, 1 by 2 is 2. So 2 plus K is equal to minus 13. So K is equal to minus 13 minus 2. And therefore K is equal to minus 15. Right? So what we can say is f of x, right, can be written as 2 open brackets x minus 1 squared minus 15, right? And that's what they're looking for 3 marks. This is just one way you can work this question, right? Some students may work it a different way. Now, let me show you a slightly different way to work this, right? So the function is f of x is equal to 2x squared minus 4x minus 13. 2x squared minus 4x minus 13. Right. So there's another way you can do this, right? So some teachers may have taught you like this. You have 2x squared minus 4x minus 13. What you can do, you can pull out this 2 here and you'll end up with x squared minus 2x, right, minus 13 over 2, right? Now, let's leave this 2 outside here. And what we're going to do, we're going to try to complete the square with this. So you're going to put x, right? You're going to use the same sign that we have here, which is a minus. You're going to put half of this 2 here, right, which is going to be 1. And then this is going to be squared. And what we do, we write back the minus 13 over 2. And what you're going to write here, this is always going to be a minus sign, but I'm going to square this value here, right? If I square that value, I'm going to get 1. So this is going to be 2 by x minus 1 squared, and minus 13 over 2 minus 1 is going to give me minus 15 over 2. And now we can multiply out by 2 again. So this is 2x minus 1 squared minus 15, right? So you realize, wait a minute, this is the same answer we got here. 2 open brackets, x minus 1 minus 15, right? Both methods are acceptable, right? Whichever method you learned, go ahead with that method, right? So that's the answer for part 1. For part 2 now, they want the values of x at which the graph cuts the x-axis, right? Where does the graph cut my x-axis, right? Now remember, let's do a little quick sketch to see what this graph is going to look like. Now the graph A is 2 here, so therefore we know the graph has a minimum value. It's going to look like this, right? We don't know where the graph is cutting the x-axis, but they want to know. And look how many marks, 4 marks. So this is my y-axis and this is my x-axis. So they want to know what is this value here and what is this value here. So that's plenty marks to work that out. So here what we're going to do. In order to do that, right, what we need to do, we need to, f of x is equal to 2 open brackets x minus 1 squared minus 15, right? Now that's the advantage of using this method. This is what we call completing the square. To find where your graph cuts the x-axis, so where the graph cuts the x-axis, what you need to do, you need to put f of x equal to 0, right? That's where my graph is going to cut my x-axis. So what you're going to do, you're going to do this. 2x minus 1 squared minus 15 is equal to 0. And what you're going to do, you're going to solve this. Once you solve this, you're going to get the answers that they're looking for. So this is going to be 2 by x minus 1 squared is equal to 15. So x minus 1 squared is equal to 15 divided by 2. X minus 1 is equal to plus or minus the square root of 15 over 2. So guys, when you're solving a quadratic, always remember when you're finding square root, there are two values. There's a positive and a negative. That's why you see me put in plus or minus 15 over 2. So therefore x is equal to plus or minus 15 over 2 plus 1, right? So we can have two possible solutions. So either, right, we're going to put x is equal to 15 over 2 plus 1, and you work that out in a calculator. So that is 15 divided by 2, and square root of that, what you're going to get is 2.74 plus 1. So what you're going to get here is 3.74, right? So that's either. You get an or option as well, which is this. X is equal to minus the square root of 15 over 2 plus 1, right? And that's going to be minus 2.74 plus 1, right? And that's going to give me minus 1.74. So I've gotten two different values for x, and they give you 4 marks for that. It's 4 marks, right? And this is what we need to do. So the values of x at which the graph cuts the x-axis, those are my two values there, 3.74 and minus 1.74. Right? Now, the only reason, I see you all asking questions about the format in which I wrote this, right? Now, the only reason I teach my students this is because sometimes the equation looks a little strange in terms of how they give you this, right? And when I say strange, is because sometimes they have a situation where a is negative, right? So I teach this method here so that any function that they give you, you can figure out what a, h, and k is, right? So we just worked out the values of x. The next thing, they want the interval for which f of x is less than or equal to 0, right? So where f of x is less than or equal to 0. Now what that is asking me here is what part of your graph is less than my x-axis, because my x-axis is the line y equal to 0, right? So again, just like we did in the previous question, we're talking about this graph here. So therefore, let me just write down 3.74 and minus 1.74. So this value here was 3.74, and this one here, well, my graph a little off, right? So minus 1.74, that was the other value. So the answer for this here is that x has to be greater than minus 1.74, greater than or equal to, because that's what they have here, less than or equal to 3.74, and that's my answer for 2 marks, right? Then part 4, right, they want to know what is the minimum value of f of x. Now here's the thing, whenever you complete the square, that is a very handy way of approaching a question like this, right? Now once you complete the square, this is what my function looks like, right? So we said my function is f of x is equal to 2 open brackets x minus 1 squared minus 15, right? Whenever you have a quadratic written in this format, it is very easy to figure out what the minimum value of the function is. The minimum value of the function is always whatever k is. Whatever k is, that's the minimum value of the function. That's why CSEC only giving you 1 mark. So the answer is equal to, so f of x is equal to minus 15. That's all you need to put to get a 1 mark, right? And then part 5, the value of x at which the minimum occurs. So remember on your graph, I said this. When you have a graph like this here is my axis of symmetry. It passes through my minimum point, right? So the x value, that's what they're asking you for. What is the x value of my minimum point? Once we complete the square, you see whatever is inside the brackets here, you have x minus 1. All you need to do is to put x minus 1 equal to 0, and therefore x is equal to 1. So that's my answer. The answer is x is equal to 1. And look, I didn't even do anything, and it's 2 marks for this. So they want to know the value of x at which f of x is a minimum. It is a minimum. When you see that piece in the bracket, you have to put that equal to 0. Alright guys, so I hope we're okay there, right? So this is as much as I'm going to be doing today, right? Because I have another class to teach at 5, right? And that is Form 5 Physics, right? So just as a reminder, right? So just as a reminder, I do give online maths, chemistry, and physics classes, right? This is my number here, right? So anybody who's interested in physics, maths, or chem, right, can send me a WhatsApp, right? If I can't answer the call, just send me a WhatsApp. All my classes are completely online. You get access to all the classes that were completed already, right? And that's basically it. All right, so I'm gonna have one more session tomorrow at 2 o'clock, right? So look out for that session at 2 o'clock tomorrow, and that's it for me, guys, right? I noticed some of the videos are taking extremely long to process on YouTube. So sometimes it takes like overnight. So the one we did yesterday, I only saw it appear this morning. So this might take a while as well, right? So also, if you want additional information, right, or additional working for certain things, you can always check the videos on my on this YouTube channel, right? I have tons of free material on my YouTube channel, right? Like I said, I've been around for a while. It's just that I haven't posted anything because I've been extremely busy, right? So if you want videos on certain topics, let's say algebra, transformations, vectors, matrices, you can find all of those things on my YouTube channel. Just search for a particular topic that you want and the videos will be there. All right, so afternoon everybody, be safe, and I will see some of you all tomorrow. All right, take care guys.